So what we are going to do is we will understand computer by simulating it, and today we will start by simulating memory. Uh, Before you start with this video, I would like to state the prerequisites. Who should watch this video or who can watch this video? Anyone who has some understanding of Python programming can watch this video, because the simulations which we are going to make and run will be in Python. So it is better that you understand it. And secondly, why should you watch this video, or what should you expect from this video series? You will get to see the computer at the most lowest level of abstraction, or to the higher programming languages. So in computers there is a concept of abstraction, and we will be looking at it from this video itself, and we will start making abstractions. um, the purpose for making simulation and running it is just to understand how computer operates on the bare metal, and then how it is abstracted away, um, so that we can have much more clearer picture of what a computer is and what a computer does, plus what instructions do. And today we will start with the memory, the most simplest part of this. This is the basic code that I have written for this simulation. But before we go to the code, there are some concepts that I would like to share. So, for now, we can have a very simple definition for what a computer is. A computer is a device which can store information and can manipulate it according to some set of rules. In the previous video, we have arrived at this definition. We will carry this definition, and we will start by us. So, if we want to implement such a device, then what will be the first component that we will need? I think it is better to start with memory. We need to store the memory. So today we will look at the memory, and how computers store the information. So before we go into the simulation, I would like to emphasize on the concept of abstraction. Abstraction simply means hiding unnecessary details and showing only essential features of something. When we when we use language, what we are doing is we are abstracting the real world. Such as when I say the word apple, you all can imagine what an apple is, or you can imagine what it feels like, what it smells like, and what it tastes like. You have not touched it. I have not physically presented apple to you. But when I say apple, you get sense of what it is. It is because when we are developing language, what we are doing is we are abstracting. We are assigning a certain meaning to a certain word, and then we are letting that word convey what we want to say. Um, this is in some sense the process of abstraction, where we are hiding unnecessary details and showing only essential features of something. And in memory, so in the computer's memory, what we do is we collect information, and that information is abstraction of real world. Such as, for example, let's say I can write my physical features, like what my height is, how what my weight is, what my body mass index is, etc., etc. It will be information about me. It will be in some sense an abstraction of who I am physically. And in computers memory, we can store information. Computers memory is not restricted to one kind of information. You can store text, audio, video, or you can also store sensors readings. Such as right now I am using this mic. My sound waves are getting captured by this sensor, by the sensors inside the mic, and the computer is storing it, and later reproducing it. So when you are listening this video, what computer is doing is it is replaying the stored information which it had. So computer is this device which can store information, which can store information of various different formats, and we want to develop memory for that. So we will look at this challenge, and before that we started with the idea of abstraction. So I will argue any form of information collection is an abstraction from real world. So now the challenge that we are having is how can we represent this abstraction. So for example, let's say in English language we use 26 different alphabets to capture different sounds, and by using the different permutation and combination of it, we capture the language, we capture what we mean, and that is how we store by using English language. Similarly, now we have to develop an idea or system where we can store all forms of information inside this device. um, when we are making such devices, such diverse devices which are of multiple use, one thing to keep in mind is we have to keep the design simple. So for example, English language uses 26 alphabets and 9 different symbols, 9 numbers, different combination of 10 numbers. um, in computers we cannot do that, or in computers we chose to just use two symbols and not 26 plus 10. um, those two symbols are called binaries, and it goes well with the hardware of computer. Discussing the hardware of computer is not in the scope of this video, so we might look at it later on. But what I want you all to understand is, in computer when we store information, we represent the information as permutation and combination of um, binary symbols, which are zeros and ones. So for example, instead of storing A, I can store 0001, and for B I can store 0010. So here what we are doing is, whatever information that we are having, may that be text, may that be image, may that be audio, video, or any another format, what we are doing is we are translating it into the binaries, into some permutation and combination of two symbols, namely 0 and 1. And what we want to store is that series of zeros and ones. This is how we develop the storage of computer. Computers only store zeros and ones, they only store binary symbols for anything, and later on, by using the set of instructions, what we do is we figure out how to translate it into the another format. So such as, for now, like in on screen you can see a bunch of text which is in English, which has English alphabets. uh, Deep down into the memory there are no alphabets which we store in the computer. Computer has just stored binaries, but later on, by using different set of instructions and mapping, we have figured out which binary represents which symbol, and for displaying we are just displaying the symbol, we are displaying the ASCII characters. That is how this is done. So in this memory simulator, our memory is just a list of binaries. For now, for initialization we have initialized 0, and every memory has some size. So in some it can be 1 gigabyte, 10 gigabyte, 1 terabyte, or whatever. So in this case we are we are allowing, so right now we don't have fixed size, but so when we initialize the memory, we have given it size of 10 bytes. So now we will go into the concept of bytes and memory addressing. So in memory, we want to store different symbols or different information, but we also want to access it, and therefore what we need to do is we have to address the information. So let's say I have given you 100 different pages filled with information. um, you cannot randomly store you cannot randomly store those pages. You have to bring in some organization so that you can pull out the right information when I ask for. So on those 100 pages, what we can do is we can number those pages. So we will give one number to each page, so it will be easier for us to retrieve the information later on. So such as I can note down there for x situation, the information written on page number 50 will be useful. So for that, numbering your storage units is a good idea. And here what we are building is storage units, and so it is essential for it to have a fixed size. So a particular storage unit should be of a particular size. You cannot have storage units which vary in size. It is really inefficient later on when you are performing all of the another engineering tasks. So it is good to have some standardization. So in this case, this is one storage unit, and our one storage unit is of size 8. So one storage unit over here can store 8 bits, and we call it a byte. So one byte is 8 bits. And when we are initializing this, so we are having 10 such storage units. So in total what we are having over here is 10 bytes. So now going forward, uh, in this over here, so okay, so what will be so this is 1 bit, and this is 1 byte. In 1 byte you can store different permutation of combination of 0 and 1s up to um, ha, in a byte you can store different permutation and combinations of zeros and ones of length 8. And here what we can do is in a byte what we can do is we can store numbers between uh, 0 and 255. So let's say we represent 0 as 0. This is how we represent 0. This is how we represent 1, and then this is how we represent 2, etc. When we max out on different permutations and combinations, we can just store numbers to 55. So in computers what we do is we encode all forms of information as numbers, and we can in 1 byte we can store a number between 0 and 255. And these numbers are stored as binaries, but we can understand them as numbers between 0 and 255 within a byte. What in this tutorial, or what in this video we will be looking at is how can we store the numbers within the memory, within the memory locations. And later on we will look at how those numbers represent information and much more. In the next video we will look at the CPU. For now we are just understanding the memory. So we have developed this memory which is of 10 bytes. Now we want to store certain number. So such as, let's say we want to store number 5 to 55 and 128. How can we do that? To do that, we have to we have to uh, give an address and value. So like earlier we said, I have given you 100 pages, and you have some information stored in it. So for you to retrieve it later on efficiently, you should have some serial numbers. So the memory over here has addresses, and inside those addresses you can store some value. So going back to the example of paper, what it means is I can give you a page number, let's say 25, and on that page number you can store any number between 0 and 255. I can give you instruction of store number 25 on page number 50, and so on. This is what this store bytes is doing. Here we are just checking if the value is between 0 and 255. If it is smaller than 0 or greater than 255, then we cannot store that, because we cannot because that value cannot be broken into the byte format. You cannot have so any value which is greater than 255, you cannot store it with 8 bits. You need more bits to do that. And here the one storage location that we have defined is of a byte. So it is essential that the numbers that we are having is between 0 and 255. And if this condition is true, then we are converting that number into binaries, and that number is getting stored in binaries. um, this is what we are doing over here. And when we say display memory, we will get what memory has. So when I run this, here we go. On address 0 we have stored number 5. This is the binary of it. The In the storage we are storing the binary, and later on we are translating how that translates into the number. So 255 is 1111111, 128 is 100, etc. And these are on these memory locations we have not stored anything, so by default it is 0. This is how the computer's memory work. Over here you have the most fundamental storage unit of any computer is bit, which can be one binary symbol, either 0 or 1. And then you have bytes. What you can do is you can address the bytes, and you can access the individual byte and store a particular piece of information. um, you you must be wondering, uh, so so, so it is the part of when you want to store different kinds of information, what you have to figure out is how the translation happens. So for example, right here it is still binary, but we have figured out the logic of converting numbers from 0 to 255 into the binaries. So here 5 is translated as 000000101. Let's look at 1 2 3, for example. 1. So see, um, 1 is all zeros, and at the end you have 1. And then 2 is in the end you have 1 0, and then 3 is you have 1 1, and so on. This is how we are translating numbers into the binaries. So in base, at the most basic level, a computer remains a device which deals with binaries, but we can translate these binaries into numbers. And we can further on use numbers to translate, encode another forms of information. So such as Right now, the sound that the sensors are reading, we can translate that into the numbers, and we can also define what these numbers mean in this context. So for the sound, it is the frequency of the sound which is being produced. So later on we send those numbers to speaker, and the speaker reproduces the sound of that particular frequency. This is how information is stored in a computer, and it is propagated and dealt with. This is the basics of computer memory. Later on we will look at the cpu, develop this simulation even further, and then we will develop an assembly language for this simulation, and then we will also make some high level programming languages. So this simulation is actually part of my exploration of assembly language. Assembly language is the most lowest level of language that you can see, but I have created this simulation so that we can look at down at the binaries and the operation of cpu, how cpu and memory handle those binaries. Slowly eventually we will play around with the simulation and assembly language and develop some programming language of our own, so that we can also understand how the levels of abstractions work, and then we will explore programming and artificial intelligence. um, this exploration, we should understand computer in full detail. That is what we are doing over here. We will do it incrementally, and I will see you in the next video. Now enough for today.